Okay. Title your notes. I appreciate those who've already started to title your notes. Exploring periodic data. Natural logs was the last lesson from the unit of exponentials and logs. We're moving on to actually trig. So these next 2 weeks in math class is actually going to help you a ton on the ACT. This is stuff you're going to see on the ACT. Woo.
So we're just barely learning about trig.
No, you already learned some of it last year. But it's more trig. Okay, and it's all free game for the ACT. The essential question is, what is the difference between a period, amplitude, cycle, and midline? What? Yeah, hurry. Danny?
I read it once, so may I please borrow a pencil? Thank you so much.
Okay. So, I'm going to show you 4 pictures. And I'd like you to just do a rough sketch of them. This is, for example, 1. And then we're going to answer the question, what do these 4 pictures have in common? Okay, I'll explain what the pictures are in case you can't figure them out. Example 1. Okay, just draw a rough sketch. This is the Earth orbiting the Sun. Okay, draw a rough sketch. It doesn't have to be large. The Earth orbiting the Sun. Then we have a heart beating, pulsing. Then we have a little girl on a swing set. And finally we have ocean waves, so we're just drawing the pictures. Okay, so the question is, what do the situations shown have in common? We're not going to answer them out loud to me right now. I'd like you to turn to your neighbor and discuss some ideas of what these 4 pictures all have in common. Okay, turn to your neighbor and discuss.
I got it.
I appreciate those who have turned and started talking about it. Find a neighbor, please. What do they have in common? And discuss it with your neighbor. Brainstorm off of each other. Okay, I would like you to turn the other way, find someone different, and share ideas, either what you got from your last partner or what you came up yourself. Okay, Sula, can you go all the way across to Allison? You guys share all the way across? All right. So let's hear some things you came up with. Either you or yourself or partners came up with. Emily? They're all moving, right? Yeah? Motion. Good. Adam? They're repetitious. Their motion repeats, yeah? Okay. Yeah, Danny?
All of them are affected by gravity.
Ooh, gravity. That's a new one. The other classes didn't talk about gravity. But everything is affected by gravity. That's interesting. All right, it's time to face forward. The time to talk to your neighbor is over. Okay, but there's a hand. What else did you come up with? We've had some good comments so far. Sheila? A cycle. They're repeating their movements. Yep. Anything else? Okay, let's start. You know, that is we need a swing set to live. Very valid point. Okay, let's actually start with the swing set girl. You guys have pretty much gotten to where we need to be. Swing set girl, let's talk about her motion. How does she move? Okay, she goes back and forth. Cause like if a person's pushing her, they push her away, she comes back. Push her away, she comes back. What other motion does she have besides back and forth? Adam, up and down. Right? She goes up, and then she comes down over time. And then she goes up, and then she goes down, and then she goes up, and then she goes down. Okay? Let's talk about the heart beating. What's the movement a heart makes? Pulsing. It expands and contracts. Expands and contracts. Expands and contracts. Okay? Let's talk about, here, have you seen the movie Gravity? Sandra Bullock? Okay, this is me. I have found this is called a space anchor. I am somehow in space and I'm not like floating away like Sandra Bullock was. But the Earth is rotating around the sun in an orbit that's constant. That's another thing. All the motions are constant. You guys said repeating, right? So, please stop. So here's Ms. Gray anchored in space. It's the eraser. It's the smart word doing it. Better? Here's Ms. Gray anchored in space. Okay, I would like you to look at the Earth's relationship to my position. As Earth moves, let's get, as Earth starts orbiting, where is it going compared to my location? Away, and then it comes back, and then it goes away, and then it comes back. Okay? So with my location over time, say this is time. This is our x-axis. Okay? And I'm on the x-axis. It's going to go away from me. It's come back to me. Away from me and come back to me. Away from me and come back to me. Yeah?
Yeah.
Okay? Now let's talk about the ocean waves. I actually like the comment that you made that everything was affected by gravity. How are oceans affected by gravity? Silver, say that again. I don't know about the sun, but definitely the ocean waves are formed or created by the moon, right? The moon does the high tide and low tide with gravity. I don't really know all the scientific parts of it, but I do know that if one side of, can you put your hand down, we'll get to you in a minute. If one side of the Earth has a high tide, the opposite side has a low tide because all the water in the ocean is pulled like this. If my left side has the high tide, and the right side has the low tide, and they all go like this. You know high tides and low tides? When the water comes up high on the beach, and then it's low on the beach. And that happens twice a day. There's 2 high tides and 2 low tides, I believe, a day. Okay, that is affected by gravity. So, what's the motion of the waves? Other than they are rolling, but up on the beach it goes high and then low, right? And then we have high and then low. And then high and then low. Okay, Styles, your question.
Salmon follow the gravitational pull.
Is that why they go upstream?
I never did. I think so.
I knew they went upstream. I didn't know they followed gravitational pull of the moon. Yeah. They're quite strong little fish. They swim upstream. Yeah. Okay, cool. Have you noticed a common relationship as I've been gesturing the movements? Yeah, do that again. Nice and big so everyone can see it. Yeah, it is creating what? What's the form my arm's creating? A wave. Thank you. One person?
Yeah.
Yeah. Okay, all of these can be shown by graphing a wave. So that's what we're going into, is wave functions, which are called periodic functions. So there's a few different vocabulary words we need to define first in order to examine the graphs. Okay, so please write these down. The first is called a period. The horizontal, oops, what did I just do? Sorry. The horizontal length or distance along the x-axis. The horizontal length or distance along the x-axis. Okay, write it down, please. The horizontal length or distance along the x-axis. So one period is when wherever it starts, it can, it's the length until the cycle repeats itself. So for instance, here we have a mountain peak. There's in periods it goes up and down, so we have mountain peaks and valley lows. So the mountain peak, the period will go until the next mountain peak. Okay, so that length from peak to peak is the period. But it doesn't have to be peak to peak. You could start at the valleys, or you could even start on the x-intercepts from here to, but you have to go all the way over there, because right here, let's get a different color. Right here, the slope is negative. Notice it's going down, and it won't repeat itself going down until over here. Okay, so you can measure the period from there to there. It will be the same measurement, or you can measure from valley to valley, the period. Yes? Oh, that's coming up in a minute. Okay. Next one is, what is a periodic function? Which you guys already know what that looks like. It's the wave. A periodic function, please write that down. There's 5 of them we're writing down today. Periodic function is a function that repeats a pattern of y values. That's your different heights. Chibs? Write them down. A function that repeats a pattern of y values, or outputs. So you're repeating your heights. You're going up, and then you're going down, and then you're going up, then you're going down, at regular intervals. So the heights all remain constant as well. You go up and down, up and down. You don't all of a sudden spike really, really high. They're all the same heights. The maximums are the same. The minimums are the same. A function that repeats a pattern of y values, which are outputs, at regular intervals. Yeah? Yeah. Okay, next one. Styles, I think maybe this is what you're talking about. Cycle. A cycle is one complete pattern. It may begin at any point in time on the graph. But the difference between cycle and a period is that, actually let's do this. A cycle, if I start on a mountain peak, the cycle traces the function. So the cycle is going to go down and until, tell me when to stop. When do I get back to my starting place? Good. Okay, so that is the cycle. We can mark it even. The period is just the horizontal distance from here to here. So in green, this is the period. But in black is the cycle. The cycle traces the graph until it gets to a repeating point where it will repeat the cycle. Emmanuel? Okay? Does that make sense, the difference between cycle and period? We're going to be calculating a few of these, so hopefully it will get ingrained more. A little more. Okay, amplitude. Amplitude of a periodic function measures the amount of variation of the function values. It is half the distance of the minimum and maximum values. Amplitude of a periodic function measures the amount of variation of the function values. It is half the distance of the minimum and maximum values. I like to think of amplitude as wherever sea level is, wherever you're oscillating around, I call it, that's like sea level. I like to think of amplitude as the height of the mountains or the depth of the valleys, because it will be equal. The depths of the valleys and the heights of the mountains would be equal. It's the height. Okay? So where did you get the top part? Okay. So if we drew a little graph, draw a wave, and we're going to mark what the amplitude represents. Chips. Okay, amplitude, there are a couple of different ways you can solve for the amplitude. It's really nice when the wave is oscillating around the x-axis, because the amplitude is just the height of the mountain or the depth of the valley, and those would be equal. Okay? It's really nice when it's oscillating around the x-axis. But sometimes it's not oscillating around the x-axis. So a way to find the amplitude is take your maximum value. It looks like my wave is a little uneven. Take your maximum value to the minimum value and find that span and divide it by 2. Cut it in half. So you would take the maximum minus the minimum and then divide by 2. It's actually like finding the average in the middle. Okay, so period is from like the horizontal distance peak to peak. Cycle traces the graph until it repeats itself. Amplitude is the height of the mountain or the depth of the valley. I think there's one more. Okay, yes. The last one, midline. This is what I mentioned when I said sea level. Midline is the horizontal line midway between the maximums and minimums. This is the line which the graph is oscillating about. It's really nice when the midline is the x-axis, but that's not always the case. But when it is, it makes the problem nicer. The horizontal line midway between the maximums and minimums. The line at which the graph oscillates. Okay, so instead of drawing another graph, I'm just going to do it up above. The midline is where the graph is oscillating around. So it's in the middle, sea level between the mountains and the valleys. So right here, the dotted line is called the midline. Does that make sense where it is? It's right in the middle, horizontally in the middle. But midline is a line. A line is an equation. So look at the horizontal line. What axis is it cutting through? Guys, which axis is it cutting through? It's cutting through the y-axis. If you're horizontal, you're slicing through the y-axis. So the equation for this yellow dotted line would be y equals, what's its height? If it's on the x-axis, what's its height? 0. Okay, so I will be picky about the midline. You don't just put 0. The midline is an equation. Y equals 0. Okay, so those are all the vocabulary words you need. Actually, it's not too complicated. We're going to do a couple of practice problems, and you'll see how they're done. It's really not too bad. Okay, so example 2, because our pictures is example 1. Okay, these directions you will see on your homework, so I need to make sure we explain them. Analyze the periodic function below. Your homework will ask you to identify the cycle in 2 different ways. What is the period of the function? Okay, so ask for 2 things. Find the cycle. Remember, the cycle is how you trace. Okay, so on your notes, would you write 2 different ways we can find the cycle? On your notes, put 2 different methods to find the cycle. Here's the first one. One way to find the cycle. I guess I should get rid of this. So I want to go down a little bit. There we go. One way to find the cycle is to begin at any point on the graph and trace the graph until the cycle is complete and you come back to the starting point. So on your homework, you would show that. So for instance, if I started there, I would trace the graph until I got back to the peak. And then the cycle is completed. So write down the first way to find the cycle. You begin at any point on the graph. You trace one complete cycle. The second way is to just identify 2 places where the y values are equal. Identify 2 consecutive, I should put the word consecutive in there, places where you come back to the same height. The y value is the height. So, for instance, right here is a height, and then the next time the graph hits that same height is right there. Same height with the same slope, right? Then it turns and goes down. So everything in between would be the cycle. So that's a second way to find the cycle. Your homework asks you to identify it in 2 different ways. So these are the 2 different ways. I hope you've written them down. Now there's one more question. It said, what is the period of the function? The period of the function is not tracing the function, but it's the distance, the horizontal distance from peak to peak. Let's do this one. So from here to here, you can really find the period any place. As long as you go from, say here, the x-axis with a slope, a positive slope, until we hit the x-axis with a positive slope. The period would be the same. Just find the starting point and go horizontally until the cycle has completed itself. So for the period, if we did it right here, what x value are we above? 2, good. And then it goes until what x value? 6. So the period is that length, from 2 to 6. What's the distance? 4. So the period is 4 units. Now if the problem actually gave you like the x-axis is representing feet, you would say 4 feet. Or 4 seconds if it was time. Okay? We're going to jump over, do another problem, finding the period and the amplitude. We're just going to practice those. It's really not too difficult. You just need to understand the vocabulary. Okay, so this is example 3, and I'm going to zoom it in so we can actually see it. I would like you to sketch that graph as best you can. It doesn't have to be perfect. I'm going to zoom it in. Okay, example 3. The question is this function periodic? If it is, what is the period? Okay, when you copy a graph, please see and find some key points, and it makes it easier to copy. You can see every 3 at 0, 3, 6, and 9 is where we hit an intersection. Okay, doesn't have to be perfect, but get the general idea. Is this function periodic? Who has the definition of periodic function on the front side? Adam, can you read it nice and loud, please? A function that repeats a pattern of, the key is y values. This definitely has a pattern, right? Because it's a wave. So is it repeating y values? The height. Is it always going back to the same height? No, it's getting lower and lower. Another thing to look at is the midline. Who has the definition of the midline? M?
The horizontal line midway between the minimum and maximum where the graph off.
Right. So it's oscillating around that dotted line I drew, correct? Okay, but what M just read was, what type of a line is it? Started with an H. M, can you see that? What type of line?
Horizontal.
Horizontal. Is this dotted line that we're oscillating around horizontal? Horizontal means flat, left and right. No, this is diagonal. It's tilted. So the answer to this is no, it's not a periodic function. It is not a periodic function. You can explain it in 2 different ways. You can say the y values do not repeat, or the midline is not horizontal. I'm going to do midline. Oh, wow, that's a large eraser. Because the midline is not horizontal. So even though it looks like a wave and you think it's periodic, be careful it actually fits the description. Okay? It has to come back and forth to the highest. The y values have to repeat. The height and minimums keep repeating. And the midline has to be horizontal. Okay, number 4. What is the amplitude of the periodic function and the equation of the midline? And we'll find the period just for good practice. Okay, example 4. I'll help you trace this one. I'll give you the key points. Will you copy this graph? Basically, just find the points, the maximum minimum points, and then just zigzag through it. So, I need to make my cursor a little smaller. Since we're zoomed in so far, my marker's huge. Okay, right here we have a point, a maximum. Okay, I'm going to write the x value so you can solve it, and that's 2. No, I shouldn't write that since I'll confuse you. I'm only going to write the x values. Okay, this x value is at 3. This x value, since it's counting by 2s, is at 5. This one's at 8, 7, that'd be 13, 16, that'd be 15, 17. Okay, try your best to copy the points. So you need something to look at when you do your homework. 22, and this is at 23. So all these numbers I've written are x values. Okay, so try to plot the points and then zigzag your pencil through them, so you have a graph to look at. You also need to put numbers on your graph. You don't have to do all those numbers that I wrote, but the original numbers, 2, 10, 18, you should label your graphs. On your homework, you won't have to do the graphs. They'll be in your book. Okay, hopefully you're close. Now we're going to go through and find all the different vocabularies that we've talked about. First, we're going to find, move this up a little bit, the period. The period, again, is the horizontal spread from the beginning of the cycle to the end of the cycle. Okay, so say I wanted to start here, and notice the cycle is beginning with a positive slope. If I follow the cycle is tracing, tell me when the cycle would end. Good, right here. So the cycle is tracing, but the period is just the horizontal spread. So from 5 to 15, how long or how wide is the period's width? 10, who's that girl? Amy. She even said units, thank you. 10 units. Good job, Dee. Okay. Now let's find the amplitude. Okay, the amplitude, again, it's nice if it's oscillating around the x-axis. Is this one oscillating around the x-axis?
Yes.
It does go across the x-axis, but what's the maximum point? What's the maximum y value? 4, right here. And what's the minimum?
2.
-2. So if it was in fact going around the x-axis, it would go up to -4, down to, or up to +4, down to -4. So our midline is not at the x-axis. Makes it a little more difficult. So we just take our maximums and our minimums and subtract. 4 minus -2. And then we're going to split them in half to find the midpoint. 4 minus -2 is how much? Because you wiggle, squiggle, and you add, right? Wiggle, squiggle. So we get 6 divided by 2, which is not 1, is 3. So the amplitude is 3. So on my graph, here at 3, each time it's making my line thicker. I need a small line. Okay, on my graph, at 3, did I do an error?
Yeah, 1.
That's the 2. It's 7 by 2.
It's 1 on the graph, but it has an amplitude of 3.
Oh, I'm drawing the midline. I'm not supposed to draw that yet. Okay, sorry. The amplitude is 3. That was right. I was trying to draw the midline on the graph, and I'm like, this isn't in the middle of the graph. Okay, so to find the midline, when it's not oscillating, I need a small marker again. To find the midline when it's not oscillating around the y, or around the x-axis, we can take the maximum and subtract the amplitude. So the maximum you told me was 4. The amplitude was 3, so if we subtract it, we get 1. But how come 1 is not correct for the midline? Midline. Line. Thank you. It needs to be an equation. 1's not an equation. 1 is an expression. How do we make it an equation? Y equals 1. Okay, so this is your dotted line. I was confused. I was getting ahead of myself. So here at 1, which would be right here, because we're counting by 2's, here would be 1. That is the midline. Okay, so we found all three things. Found the period. Period is the horizontal distance from peak to peak. I like to choose the peaks. I think it's easier for me. The amplitude is how tall are the mountains. The highest mountains are 3. The lowest valleys are 3 units. And the midline is what we're oscillating around, which is y equals 1. Any questions on that? Okay, one more practice one. Last example. Example, I believe 5, right? Okay, and then I will zoom it into the chart. Let's read the problem first. Put example 5 and just write down the important information. Story problems, you don't have to write the whole thing, just the important information. Okay, the sound is produced by periodic changes in air pressure called sound waves. So when I'm speaking to you right now, what's coming out of my mouth that is invisible, we can't actually see? Sound waves. Right? So it's in a wave pattern, and then it goes into your ear. The yellow graph at the right, which is the top one, the bottom one's green. Okay, the yellow graph at the right. Bless you. In the digital wave displays the graph of a pure tone from a tuning fork. What's the period and the amplitude? And just for good practice, we're also going to find the midline of this graph. So, you should have written down at least the question. What's the period, the amplitude, and we're going to actually find the midline. And something else that's important is the graph itself. So if I zoom it over, okay, starting with the period. Macon, can you describe for me how we find the period? Yep, so Macon, if I started, say, here, my period would go until what point? So, and it's not following, tracing is the cycle, right? So the horizontal distance between those 2 points would be the period. And we have values here.
0.004.
0.004 to 0.008. So the period, yeah?
So in this, if you said it moved over 4, would you get that wrong? Because it's 0.004?
It moved over 0.004. It didn't actually move over positive, like 4 as a whole number. It moved over 0.004. Right. Yeah. Yeah, so the period is in the, let's see, that would be the thousandths place. It moves over 4 thousandths. Decimal places are actually very important, as the Olympics show us, right? Sometimes you win like by the skin of your nose, and it's like 1/1000th of a second. Yeah, he won by like a fingernail once. Yeah. Okay, so that's period. Next, we find amplitude and then midline. Amplitude. Once again, it would be nice if it was oscillating over that x-axis, but it's not on this one. So the amplitude, you take the maximum, subtract the minimum, and divide by 2 to find the sea level. So the mountains are above, the valleys are below, yeah? That's, I don't know. It didn't tell us what the green line, it only said the yellow one. Nothing. Yep. Okay, amplitude. So we have our maximum comes from the y's. How high does that wave go?
2.5.
Ah, you have to look at the graph very carefully. It is not 3. It is not 3 because we have 0, 1, 2, this would be 2.5 because every line is representing a half. And then the minimum would be 1.5. So the spread between them, or the difference, 2.5 minus 1.5, is how much? 1. And then we divide by 2, which means 0.5, or 1/2 is, in units, is the amplitude, which means it's a half unit tall for the mountains and a half unit deep for the valleys. And the last thing is to find the midline. Yes? Yeah, so the height of the mountain is the amplitude, and the depth of the valley is also the amplitude, which is how far it is from the midline. Yes? Well, it's the same. The amplitude would be 0.5 either way. Okay, and the midline, now if it was around the x-axis, it's really nice because the midline is the x-axis, which is y equals 0. However, here it's not the x-axis, so we take the maximum and subtract the amplitude. Okay? Christian, let me get a new color first and a small line so I can actually write and not take a lot of space. What was the maximum on our graph again? 2.5, great. And then we're going to subtract the amplitude, which we found last time, 0.5. So what's our midline, Christian? Ah, thank you, you caught it. Y equals 2, not just 2. Y equals 2. Okay, are you understanding the difference between period, amplitude, and it's not too bad, right? Okay, here's your assignment then. Page 380, numbers 1 through 20. However, guys, this is in a new book. I don't know if you noticed, but your natural log assignment was the last section. So for the rest of the class, we need to quickly check out these books. Okay, so let me stop this really quick.